Welcome to this video on Math 32, Chapter 2 Review, Part 2. In the first part, we solved systems of equations by graphing. Now, we're going to solve systems of equations using substitution. So, let's begin. Solving equations by substitution means that we have to isolate one variable and then substitute that expression in place of the other variable. I'm going to start by looking at the second equation, which is x minus y equals 5. The easiest way to isolate a variable is to add y to both sides, giving me x equals 5 plus y, or y plus 5. Then I'm going to take this expression and substitute it in place of x in the other equation. So if x equals 5 plus y, in place of x, I'm going to write 5 plus y. So I have 3 times the quantity, 5 plus y, minus 3y equals negative 24. Then I'm going to distribute the 3. 3 times 5 is 15. 3 times y is 3y. Now I'm going to simplify by combining like terms. Plus 3 minus 3 is 0y. So I have 15 plus 0y equals negative 24. This goes away, so I end up with a statement that says 15 equals negative 24. Clearly, this mathematical statement is false. So what is our final answer? Well, when I end up with something that is clearly not mathematically true in any way, then that means that there is no solution. In other words, there is no value of x or y that is going to make 15 equal to negative 24. So make sure you show all your work, but your final answer again needs to be no solution. Let's do the next problem. Again, we are solving by substitution. This means we have to isolate one variable and then substitute it in place of another. I'm going to start with the equation x plus 2y equals 1. I'm going to isolate x by subtracting 2y from both sides of the equation. This gives me x equals 1 minus 2y. Now, I'm going to take the other equation, which is 5x equals 5 minus 10y, and wherever I see x, which is right here, instead of x, I'm going to write 1 minus 2y. So now, I distribute this 5 here. 5 times 1 is 5. 5 times negative 2 is negative 10. So we have something that says 5 minus 10y equals 5 minus 10y. Well, that's kind of confusing. In fact, if we add 10y to both sides, then we just get a statement that says 5 equals 5. So this is clearly a statement that is true. And it's always true, regardless of what I make x or y. Therefore, we say that these two, or this system of equations has infinite solutions. And that would be the final answer for this problem. Let's do the next one. Again, we're solving via substitution. That means I have to pick one variable to get all by itself on one side, or isolate. I pick the second equation, and I'm isolating x by adding 2y to both sides. So this gives me x equals negative 4 plus 2y, or 2y minus 4, whichever you prefer. So then I'm going to take the other equation, which is 2x plus 2y equals 4, and I'm going to put negative 4 plus 2y in place of x. So we have 2 times negative 4 plus 2y equals 4. So 2 times negative 4 is negative 8. 2 times 2y is 4y. Then we bring down the rest of the equation. At this point, we can combine our like terms, giving us 6y. And then we can add 8 to both sides, giving us 6y equals 12. Last but not least, we can divide both sides by 6, giving us y equals 2. Now at this point, it probably seems like we should really be done with this problem since we've been working on it for so long. Unfortunately, we're only halfway done. We've only found y. Now we must use one of these two equations to find x. So I'm going to do this over here. I'm going to have x minus 2y equals negative 4. So we'll have x minus 2 times 2. Again, that 2 came from this y value that we just found. So I'm going to have x minus 4 equals negative 4. I will add 4 to both sides, and I find that x equals 0. Again, it's really always a good idea to check your work. And we check our work using an equation the equation that we didn't just use. So I'm going to use an equation that's different from x minus 2y equals negative 4. In this case, it's 2x plus 2y equals 4. So in this problem, I am going to put 0 in place of x, because that's what we found for x. We're going to put 2 in place of y, because again, that's what we found for y. And then we're going to verify that this is actually true. 2 times 0 is 0. 2 times 2 is 4. So we get 4 equals 4. Okay, so not only did we spend time finding our x and y values, but we also made sure that our work was correct. And this is an extremely valuable process, especially on a test. Again, you can write your answer as the ordered pair 0, 2, or you can simply just say x equals 0 and y equals 2. Either way is an acceptable way of expressing your answer. Let's do one more problem here. Okay, again, we are trying to solve this system of equations using substitution. So our first goal is to isolate one variable. So I'm going to first try to isolate my x variable, and I'm going to do that by adding 4y to both sides. So this gives us negative x equals negative 14 plus 4y. Now, x is almost by itself, but it really has this negative 1 next to it. So the way we get rid of that negative 1 is by dividing all the terms by negative 1. This gives us x equals positive 14 minus 4y. Now I have an expression that I can substitute into the other equation. So wherever I see x, instead of writing x, I'm going to write 14 minus 4y. So we have negative 6 times the quantity, 14 minus 4y, plus 8y equals 12. Then we have to use our distribution property. So negative 6 times 14 is negative 84. This is 24y. And then we got 12. Now we can combine our like terms. 24y plus 8y is 32y. And we bring down our negative 84. Then we need to move all of our numbers onto the other side. We do this by adding 84 to both sides of the equation. So we get 32y equals 96. We divide by 32, and we find that y equals 3. Again, it feels like we've been working on this problem for about half of forever, but of course that's not really true. And in fact, we have only, thus far, found our y value. We still have to find x. So let's use the space over here to find x. Okay, so let's see. To find x, what we need to do is we need to go back to one of our original equations. I'm going to pick this one. And we'll have negative x minus 4y, which is 3, equals negative 14. So we have negative x minus 12 equals negative 14. If I add 12 to both sides, I have negative x equals negative 2. And last but not least, we need to divide by negative 1, and that gives us x equals positive 2. So now we need to check our work. So I just used this equation right here, which is this equation right here. So now I have to use the other equation, the one we've not used yet, which is negative 6x plus 8y equals 12. So let's put in our variables, or our answers rather. So we said that x was 2, and we said that y was 3. And if there's no mistakes, we didn't make any math errors, then this should check out. So we have negative 6 times 2 plus 8 times 3 equals 12. So this gives us negative 12 plus 24 equals 12, or 12 equals 12. Okay, so it checks out. 12 is equal to 12. So we know that our final answer is the ordered pair 2, 3, or you could write x equals 2, y equals 3. right? And again, we checked our work so we know that it is valid.